All right, sample exercise 15.12. This is the one where you're going to use the quadratic equation. Your homework problem number 21 is similar to this problem, okay? So let's get started here. So sample exercise 15.12. This is our equation. Okay, H2 plus I2 goes to 2HI, right? Again, we're going to use an ICE table, and you will use an ICE table on problem 21 also. So I'm just going to put that in here real quick. Initial change and equilibrium. There we go. All right, so this problem tells us a 1 liter flask is filled with 1 mole of H2 and 2 moles of I2 at 448 degrees Celsius. The value of equilibrium constant Kc for the reaction is 50.5. All right, so it gives us moles, but it says it's 1 liter, so the moles is basically the molarity. So I'm going to write the initial concentrations here, which it gives. It tells us we have 1 mole of H2, 2 moles of I2, and then it doesn't say anything about the moles of HI. Since it didn't say anything, it means that there's 0 starting, initial concentration. So 1 molarity, 2 molarity, 0 molarity, okay? Now, the problem asks, what are the equilibrium concentrations of each one of these? H2, I2, and HI. That's what we have to figure out, right? This is how we're going to use the ICE table. So starting off here again, what do we have? We have reactants, 1 molarity, 2 molarity, 0 molarity, right? So what's going to happen with our reaction when it starts off? It's going to start going to the right. So we're going to start losing reactants, right? So we're going to lose H2. We're going to let the change be minus X. Since these are 1 to 1, the change in I2 also has to be minus X. Now on this side, we're going from reactants to products. Products are appearing, right? The ratio between these is 1 to 2. So this has to be plus 2x. Okay? I hope that makes sense, right? Again, going from reactants to products. So these are negative, that's why that is positive. Ratio, 1 to 2. Now, we're going to write these down here. What's the equilibrium going to be? 1 minus x, 2 minus x, and 2x. So we're going to put this together using Kc, our equilibrium constant expression, and we're going to solve for x is what we're going to do. Once we have x, we can figure out all of these. So let's write out I'm going to write out Kc, products over reactants. Like that. Now I'm going to stick in my concentrations here into the equilibrium expression. Okay? I'm going to stick everything in. So we're going over here. So my Kc is 50.5 equals, for concentration of Hi, I'm going to have 2x squared. And then in the denominator, what am I going to have? I'm going to have concentration of H2, 1 minus x times concentration of I2, which is 2 minus x. So now we got to get this into expression of the quadratic form. Again, remember, we're solving for x, is the idea, right? So I'm going to show all the steps to do this, right? So we distribute this 2 to each, right? So we're going to get 4x squared on top. Let's FOIL out the denominator. 1 times 2 is 2. 1 times minus x is minus x. Minus x times 2 is minus 2x. And minus x times minus x is plus x squared. Okay? And then we can combine those two, right? That'd be minus 3x, right? Minus x plus minus 2x would be minus 3x. Next thing I'm going to do is I'm going to multiply through by the denominator, okay? To remove to the other side. So I'm multiplying by the denominator here and on the other side. On this side will cancel, and I'm going to end up with on this side, again, my x squared, right? That's minus 3x. like that, right? Let me make sure I did this right. I don't want to make an error. Again, I multiplied through, right? So we'd have x squared, that's minus 3x and plus 2. Now I'm going to multiply this out. Uh, 50.5 minus x squared minus 3 times 50 would be 151.5x plus 2 times 50 would be 101 equals 4x squared. And then I want everything on one side, so I'm going to minus 4x squared from both sides. Just like that. If you can see that, man, I hope you can see that. I hope that's not in the way. So we have 46.5x squared minus 151.5x plus 101 equals 0. So obviously I have to make some room on this board, and I'm going to write it in the quadratic form. Yeah, let me make sure that's correct though, before I go on. Yeah, that's the same thing they got. Okay, good to go. So rewriting my equation. I have 46.5x squared minus 151.5x plus 101 equals 0, right? So this is A, this is B, this is C. And so we're going to go x equals, again, minus b plus minus b squared right, again, this is b, right? Minus 4 times a times c and then all divided by 2 times a. All right, that's what we get. Oi. So what I'm going to do is I'm going to distribute some of these negatives and get this underneath the radical. I'm just checking to make sure I get the same thing they have. And combine this under the radical. So this minus is going to cancel. Again, if you have a calculator with it programmed in, just go right ahead. I really don't care. And what's all this going to look like? Well, let me grab my calculator. Now let's figure it out. So those negatives are going to cancel. So I'm going to have 151.5 squared, and then minus 4 times 46.5 times 101, enter. And I'm getting 4,166.25. Actually, so that would be underneath the radical. Then I'm going to quick take the square root of that. Second square root, second answer, enter, and I'm getting 64.5. So that underneath the radical, all of this was 4,166. I took the square root of that, and I get plus minus 64.5. And then all divided by 2a, which is going to be 93, I think. Yes. Okay? Now let's figure out for the plus. For the plus, okay? We're doing the plus. 151.5 plus 64.5 divided by 93, enter. And I'm getting 2.32, or x equals, and I'm going to do the negative 151.5 minus 64.5, enter, divided by 93, enter, 0.935. Okay, so you have two answers, right? Well, remember, I erased it, although you have your ICE table still, you should have written it down. What did we have for the equilibrium concentration of H2? We had 1 minus X, right? For I2, we had 2 minus X, and then for HI, we had 2X, right? If you remember back to your table. Now, so which answer is it? Well, if X is 2.32, 1 minus 2.32 is going to be a negative number, right? Can you have a negative concentration? No. No, you cannot have a negative concentration. So the answer has to be 0.935, okay? The answer has to be 0.935. 1 minus 0.935, that's going to give us, what is that going to give us? That's going to give us 0.065, I think, if I did that right. Remember, it's molarity, right? Let me grab a calculator. No, I'm correct. This one would then be 1.065 molarity, and this one would be 1.8 something. .87 molarity. Okay, now, right? Now, in this other problem, you're also going to get two x's. If one of the x's is negative, then it's probably not going to be that one. But again, you're going to have to compare both answers to your problem. Because like I said here again, if x is 2.32, this turns out to be negative. You can't have a negative concentration. It makes no sense. So this has to be the answer, 0.935. Anyway, problem 21 is very similar to this. It might actually be just slightly easier, but you'll end up using a quadratic. Have fun with that, and I'll be back.